Welcome to the Crazy Hat Chemist. So today another video in atomic structure and electron configurations. Bam! Today we're talking about paramagnetism and diamagnetism. Now before we talk about that, those two things here, I want to make sure that you understand the following. And you're probably familiar with this, and those are ferromagnets. So ferromagnetic are elements like iron, nickel, cobalt. Those are permanent magnets. We're familiar with all of those. Okay, now paramagnetism and diamagnetism is much different. So paramagnetic is when atoms contain an unpaired electron spins and then are attracted to a magnet. Okay, so this is an example of that. Electron configuration orbital box diagram of hydrogen. That is the orbital box diagram for hydrogen. So therefore hydrogen is paramagnetic. Okay, now this is opposed to a diamagnet. So diamagnetic is when atoms contain net paired electron spins. That is, they are anti-parallel, and I talked about that with the electron configuration for helium. And these are not attracted to a magnet because the magnetic fields cancel themselves out. Okay, but they can be superconductors. Just like this one here, this is the orbital box diagram for helium. That is diamagnetic. So diamagnetics would rather die than be in a magnetic field. Hopefully that makes sense. Diamagnetism do not contain net unpaired spins and are repelled by a magnet. Okay? Odd numbers of electrons will always lead to one or more unpaired electron spins and are therefore paramagnetic. Even numbers of electrons are not necessarily diamagnetic. This is a really cool experiment if you have a very strong magnet that's permanent. Okay? Liquid oxygen, okay, has two unpaired electrons and is attracted to a magnetic field. So if you have a very strong magnet like that one in that picture right there and take some liquid oxygen, pour it over this magnet, then the liquid oxygen will hover in between the poles of that very powerful magnet. You should see, even in that picture right there, the liquid oxygen is a very slight blue color. Super cool. Well, temperature-wise, it's cool, and that is a super cool experiment in and of itself. You should do the electron configuration and then the orbital box diagram for oxygen to verify that there are two unpaired electrons, and therefore it would be paramagnetic and is attracted to a magnetic field then as a result. Okay, so understand paramagnetism and diamagnetism because we're going to be covering all of this when we do orbital box diagrams. Okay, you can get paramagnetism and diamagnetism with another theory, and that is the molecular orbital theory. So that would be another way to get paramagnetism and diamagnetism. But you can also get that in result by doing an orbital box diagram, which we're going to be covering in this unit. So that's super cool. I am the Crazy Hat Chemist and wearing a super cool crazy hat. I got this again from one of my students. Thank you very much. If you like that video, give me a thumbs up, subscribe to my YouTube channel, and I will see you next time for more cool chemistry videos. Bye now.